Alright, so in Chapter 1, Section 10, we talk about modeling and variation, and um, this is our first glimpse of linear regression or any type of regression. And so I was going to show you how to do a problem similar to number 1 when we have all these data points and how we get an equation that best models our data. Notice when they say 1995, that represents 5, so they're just changing these x values to have a little bit smaller numbers. So when we're graphing, we don't have to be all the way over to 1995. So I'm going to take a couple of these points and I'm going to put them into Desmos, and I'm going to show you how to do that. So if I make a table and I'm going to have 5, 6, 7, I'm going to stop there. 406, 436, and 499. So I'm going to pretend I just have 3 data points. And we should be able to see these if I change our outputs a little bit. So let's go up to like 500. And so we can see these 3 dots. Now, if I want to find a regression equation to it, a linear equation, I have to tell Desmos I want you to do a regression equation. So my y values, to notate a regression, we put in the tilde, I guess, mx plus b, like that's our equation for a linear equation. And here we go. It gives me what my slope is, 46.5, and what my b value is, 168. So it just did a regression. We can fit whatever type of equation that we want, but since we're doing linear, we do an mx plus b, and we're just using our y1 values and our x1 values to get this regression. Now, if you wanted to do this on your TI, I know some people are the fans of TI, and so let's put in some data. Do it very similarly to what we did in Desmos. 406, 436, and 499. And so we have our data in, and if we go to stat, calculate, go down to this len reg, and enter again, hey, we get the same thing, 46.5 and 168. So either way you do it, you'll get a good equation, whether you use Desmos or a TI or something similar to TI, very similar process. You can do these on Excel, pretty easy in Excel as well. I just like the visual that you get automatically with Desmos. So that should help you out with that first problem on finding the equation. You even can see a good graph of your points once you get them all in there. So that's what they want you to do here. Make sure that they're doing S of t, so make sure that your variable, your slope times t plus your b value. And then you can estimate values. So if I want to know what happens in 2017, from 1990, so that means my t would be 27. And we would input those values into whatever regression equation that we get. They also talk about direct variation and inverse variation. And there's some spots in the book, like for inverse variation, this is your basic y equals k over x. For direct variation, it's a form of a linear equation, or it can be. So it's this nice, simple y equals kx. Again, we did a y equals mx plus b. So basically, if they say directly, they're directly proportional, multiply. If it's inversely proportional, we divide. K over x versus k times x. So when you're doing your homework, it may ask you a varies directly as the square of r. Well, so a, make sure you capitalize things, equals k, if there's some constant that affects it, the square of r squared. And that would be a way that we could do this problem. Again, be very careful with your capitalization or not. If we have h varies inversely, so that means I'm going to have a k over something. K divided by, this one's the square root of s, so I need to put in the square root of s to see how these two variables, h and s, relate to each other. Here we saw how a and r related to each other, h and s, direct and inverse variations.